Welcome to Computer Science Home Learning. The topic today is binary addition. There are three main tasks that you're going to complete during this lesson, and as always, each of the tasks will be reviewed by Mr. Barnes, who will go through the answers and give you some tips.
Right, so binary addition is a topic that some people are afraid of, but they shouldn't be because it is easy as 1, 2, 3. And I'm going to show you the correct 1, 2, 3 to know about for that. So to begin with, we need to just have a quick recap of denary and binary. Denary is the normal number system that you know and love every day with 10 symbols, 0 to 10 to represent numbers, and then binary is what computers are stuck using, where they've only got zeros and ones to represent numbers. And just a very basic recap. So we've got denary is 0, binary for 0 is 0, which that's nice and easy. Denary 1 is 1 in binary, so we're good there. And then in denary 2 is 1 0 in binary, so 0 1 like that, because we've got no ones and 1 2s. Remember, that's how that works. 3 in denary is 1 1, so we'll put that there. And if you remember this, that denary, that the whole idea of binary addition is as easy as 1 2 3, and you do this, put this little reminder next to whatever question that you might be answering, then you'll be fine, because these are the 4 rules that you need to remember for any sort of binary addition. So let me show you with an example. I'll start with a good binary number for us to add. So yep, that one there will do pretty much everything that I want to show you. We need 1 there and a 1 there. Okay, adding these two numbers together then. 0 plus 0, so 0 plus 0 is 0. Nice and easy. 1 plus 0 is 1. Very easy. 1 plus 1, well, that's 2. But how do we represent 2 with binary? It's 1 0. So I put a 0 here and I carry that 1. Okay, so I just carry that 1, just like you would do in normal denary addition. It's exactly the same principle. There's no sort of tricks here at all. And then I've got 1 plus 1 plus 1. So that's 3. Well, what's that in denary? It is 1, and then I'm carrying another 1. So I can do that there. So that's my answer. 1 1 0 1 0. Two binary numbers added together. It is as easy as 1 2 3. You just need to remember to convert the 1 2 3 to binary as a little reminder for you if you've got any questions on it. One last thing to worry about is if we have a situation where we've got overflow. So I could have run into it in the problem that I had above. I'm just going to have a shorter version of it here. Let's say I am restricted to using 4 bits, so 4 1s and 0s to show my answer. And if I add together these two numbers, then I end up in a situation, whoops, that should be 0. I end up with a situation where I am going to carry a digit here, but I haven't got any space for it. So the result ends up being inaccurate because I have overflowed my addition. That's the only other thing to have to worry about if you are restricted for space. So that is binary addition. It's as easy as 1 2 3.
Okay, now you've heard about binary addition, there's a Google form with about 15 questions for you to complete on it. Off you go. So now you've completed your task, here's Mr. Barnes who's going to show you how he did it.
Okay, so you've just completed a Google quiz on different binary addition, which tells you the right and wrong answers. However, I'm just going to use this video to go through a few examples to make sure we've got that understanding in place. So the first one I'm going to pick out is 101100 plus 011010. On the right hand side I've got the rules to help remind me how to do it. So 0 plus 0, using these rules, is 0. 0 plus 1 is 1. 1 plus 0 is the same as 0 plus 1, so that's a 1. 1 plus 1, it says here, is 10, which means we put a 0 and we carry a 1 across. Then we've got 0 plus 1 plus 1, which is the same as 1 plus 1, so we've got 0 carry 1. And then we've got 1 plus 0 plus 1, which again is 0 carry the 1. In this final column we've got nothing, so it's 0 plus 1 is 1. That's one of the examples from level 1. Let's have a look at a level 2 example. So I've got 1, 0, 1, 1, 1, 1, 0 plus 1, 1, 1, 1, 1, 1, 1. So 1 plus 0 is 1. 1 plus 1 is 0 carry 1. So now we've got 1 plus 1 plus 1. So that's 11, or as I like to remember it, 1 carry 1. We've got the same again here, so that becomes 1 carry 1. Same again here, 1 carry 1. So now we've got 1 plus 1 plus 0, which is the same as 1 plus 1. So we've got 0 carry 1, 1 plus 1 plus 1, which is 1 carry 1. Nothing plus 1 is 1. One final example then from level 3. 1, 0, 0, 1, 0, 1, 0, 1 plus 0, 0, 0, 1, 1, 0, 1, 1. So 1 plus 1 is 0, carry my 1. 0 plus 1 plus 1 is the same as 1 plus 1, so that's 0, carry 1. Same again, 1 plus 0 plus 1 is 0, carry 1. 0 plus 1 plus 1 is 0, carry 1. We've now got 1 plus 1 plus 1, which is 1, carry 1. Then we've got 0 plus 0 plus 1, so nothing plus 1 is just 1. 0 plus 0, 0, and 1 plus 0 is 1. Hopefully those modelled examples help. You can self-check using the Google quiz on all the other questions.
For the next task, you need to calculate some binary addition that results in an overflow error. You should be able to see the difference that an overflow error makes to the accuracy of the answer. Okay, time's up. Time for Mr. Barnes to review the answers.
Okay, so let's have a look at this overflow errors task. The idea was you were to perform the binary addition as previously taught, and then work out what the answer would be given in 8 bits if it was in denary, and then what the answer should be to look at the impact of overflow errors. The first one was done as an example, so let's go straight on to task 1. So, first of all, 0 plus 1 is 1. 1 plus 0 is 0, carry the 1. 1 plus 1 is your 0, carry the 1. 1 plus 1 plus 1 is 1, carry the 1. 1 plus 1, 0, carry 1. 1 plus 1 plus 1 is 1, carry 1. 1 plus 1 is 0, carry 1. And 1 plus 1 is 0, carry the 1, which then goes in as the 9th bit, creating the overflow error. So the overflow error is when you end up with an additional 9th bit, which means you get the incorrect answer. So the next thing to do is work out, using just the 8 bits, what the answer would be in denary. So I'm just going to write 1, 2, 4, 8, 16, 32, 64 and 128. So here I've got 32 plus 8 is 40, plus a 1 is 41. So with 8 bits it's given me the answer 41. However, the correct answer should be, if we went along even further, this would be 256. So it would be 256 plus the 41, which is 297. So actually it's given us the answer 41, even though the correct answer should be 297, because we're only using 8-bit form. And that means we've got an overflow error, where it gives an inaccurate answer. Let's move on to the second task then. So 1 plus 1, 0, carry 1. 1 plus 1 plus 1 is 1, carry 1. 1 plus 1 plus 1 is 1, carry 1. And so on, all the way to the end. Nice and easy, this one. Okay, so the next thing to do is then work out what the answer given in denary is. So I'll do the same again, 128, 64, 32, 16, 8, 4, 2 and 1. Now I know that adding all those numbers across the top together gives me 255. So to make this a little bit easier for the maths, I'm just going to take away 1. So it actually gives me the answer 254. Now just like before, if we had a 9th bit, it would be 256. So 256 plus 254 is 510 is the answer it should give. So once again, we have an inaccurate answer because we are dealing with 8 bits and have that overflow error.
Now you've had plenty of practice with binary addition, it's time to practice some exam past paper questions. As always, Mr. Barnes will review these after you've finished them. Okay, time up. So Mr. Barnes is now going to walk through these exam questions. Make sure you assess them as you go along.
Okay, so let's have a look at these exam questions and how to answer them. First thing to do, it says add the following two 8-bit binary numbers. So we just need to perform binary addition with the rules we've already learned. So 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 0, carry 1, 0 plus 1, the carried 1 is 1, 1 plus 0 is 1, and 1 plus 0 is 1. That would be enough to get the 2 marks. So if we have a look at the mark scheme here, it clearly says 1 mark per nibble, which is 4 bits. So we've got 1, 1, 1, 0. That gets us the first mark. 1, 1, 1, 1 for the second mark. However, it's always good in an exam to check your answers, and this is how you can do it. We can write the binary number line across the top, like so, and then work out each of these binary numbers in denary. So the top number, when you add them all together, is 155, and the bottom number is 84, which gives you 239. We can then check the bottom numbers right by adding them together. So 128 plus 64 plus 32 plus 8 plus 4 plus 2 plus 1 is 239. Therefore, we know we've got this correct. Moving on to the second question then. It says add the following two 8-bit binary numbers and explain the result. When a question is probably going to ask you to explain the result with a binary addition, that probably means that there's some sort of overflow going on. So let's have a look. 1 plus 1 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 0, carry the 1. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1 is 0, carry the 1, which has given me a 9th bit. So, how do I explain this result? So I can say there is an overflow error, as the total is more than 255. So let's have a look at how the marks are awarded for this question. First of all, it says the first nibble is correct with the carries. So always make sure you show your carries. So we've got 0, 1, 1, 0. Correct. Second nibble's correct. 1, 1, 1, 1. Correct. So we've already got 2 marks. A third mark, we can just write there is an overflow error. There we go. 3 marks. It does say though that you can accept 9-bit answers here. So I always circle the 9th bit just to make it aware that I am aware it's a 9th bit and not part of the actual answer anyway. Let's have a look then at the final question. So here it says the table below shows the ASCII codes for a number of characters. The lower ASCII code for a character can be found by adding this binary number here to the uppercase version. Complete the table by filling the missing ASCII codes. This question actually has nothing to do with ASCII, it's a binary addition question. So what it's saying is to get the lowercase letter, or the binary code for the lowercase letter, we need to add this value here to what the uppercase one is. So I'm going to write 1 0 0 0 0 0 1, and underneath I'm going to write 0 1 0 0 0 0 0. I'm going to add them together. So this is the uppercase value, and this is what I need to add to it to get the lowercase value. So 1 plus 0 is 1, 0 plus 0 is 0, 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 0 plus 1 is 1, and 1 plus 0 is 1. I'm going to write my answer. 1, 1, 0, 0, 0, 0, 1. Please make sure you get the right numbers as zeros because it's very easy to get muddled up. Then I'm going to do the same for E. 1, 0, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 0, 0. So 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 0 is 0, 0 plus 1 is 1, and 1 plus 0 is 1. So I'm going to write 1, 1, 0, 0, 1, 0, 1. Let's have a look at what the mark scheme says. So if we have a look here, hopefully that's visible enough. It says A is 1, 1, 0, 0, 0, 0, 1. So that is 1 mark correct. And E is 1, 1, 0, 0, 1, 0, 1. Second mark correct. Note, in the mark scheme it does say do not allow leading zeros. So do not make it any more bits than it needs to be. And there we have it. Full marks.
That's everything you need to know for binary addition. Stay tuned for the next lesson.